We text while walking all the time. For that, we enter and edit the text using our phones. Our phones are awesome, but they keep our hands busy and our heads down. We propose EYEditor, a heads-up smart glass-based solution to on-the-go text editing.
In order to
The user sees the text on a see-through smart glass and can correct the text using voice input. A speech recognizer transcribes the user's speech to text and sends the user utterance to a processing unit. Additionally, the user uses a hand controller for text navigation and selection. The speech and the controller comprise the input interface of EYEditor. The processing unit changes the text based on the user input and pushes the changed text to the app UI of EYEditor running on the smart glass. The system also gives audio feedback of text change confirmations and errors. Let's see how the system works with voice and controller input. Our system shows the text sentence by sentence. Instead of having to remember commands, users can correct the text by re-speaking, that is, by speaking over erroneous parts of the text in order to correct it.
dog, domestic animal. It is always faithful. Human beings.
Users can scroll through the text by swiping right or left on the controller trackpad. For finer grain control over the text, users can enter a select to edit mode by pressing the left button and select words by swiping on the trackpad. The selected text can be changed by speaking.
Dogs. Friendly.
To initiate a range selection, user has to press the center button. Swiping on the trackpad adds or removes words from the existing selection.
Playing.
Selected text can be deleted either by long pressing the center button or by saying the delete keyword. To insert new content, users use the top or down keys to first place the cursor before or after selection and then speak.
On.
Pressing the left button takes the user out of the select to edit mode. Changes can be undone with a short press and redone with a long press of the right button. Participants use the two techniques in a counterbalanced order for making both simple and complex corrections in the text, while working on 3 different path types. These are sample texts that the participants corrected during the experiment. Participants see the text sentence by sentence. At the start of the experiment, we asked each participant to walk a 20-meter segment of each path at their normal walking speed 2 times. We used this measure to compute how much they slowed down from their normal walking speed while performing the experimental tasks using the phone or our proposed technique. These are snippets of the actual paths that the participants walked on. Our study showed significant performance benefits of our proposed technique over the phone when either the path or task difficulty increased. Thus, our paper rethinks the status quo of text interaction on the go.